Hi, this is Nyla, and I'll be presenting Chapter 9.6 on solutions. So 9.6 is on the properties of solutions, and we're taking ethanol glycol, as seen in the picture, that is basically antifreeze, and is being added to your reactor to form an aqueous solution. To form aqueous solution that has a lower freezing point and a higher boiling point than water. We do this because we want the water in our radiator to not freeze, but to properly circulate our car. Our learning goal for this chapter is to identify a mixture as a solution, a colloid, or a suspension. Describe how the number of particles in a solution affects the freezing point, the boiling point, and the osmotic pressure of a solution. So first we're going to talk about the differences between solutions or colloids. As we can see in the first bullet point, solutions are transparent, so we can automatically assume that colloids aren't as transparent or may be more opaque. Solutions do not separate, while colloids can be separated, but by a semi-permeable membrane. Solutions and colloids cannot be filtered, and solutions have smaller particles than colloids, while colloids have medium-sized particles. I had to use a picture to actually, because I'm a visual learner, I had to visually see it. So as we can see, solutions, as represented by the example, are, as the example of water, we can see that it is transparent and that the light can go through it, while colloids in the other example are more opaque. And as represented by our example of milk. And suspension, we're going to talk about this next. A suspension is a heterogeneous, non-uniform mixture, which means it's formed up of two different things. Heterogeneous means two different things are opposite. So we have very large particles instead of the medium and small size particles of colloids and solutions respectively. And they can settle out of the solution. So they can come on together. They can be come apart. So suspensions can be filtered, and they must be stirred to stay suspended. Some examples they included are muddy water and calamine lotion. Calamine lotion, you have to shake it together in order for the mixture to stay together. And muddy water, the mud will become on top of the water. As we can see, if you step a boot in muddy water, your boot will touch the mud before it touches the water. And like in our other example here with flour and water, you have to continually stir flour and water for it to stay, the flour to stay suspended in the water mixture. And this is just an overall chart of the differences we talked about. So the type of particles, solutions have small particles, colloids have medium or larger particles than solutions, and suspensions have the largest particles of all and are the most visible. As for settling, solutions and colloids do not settle, while suspensions can settle if not stirred. Separation-wise, solutions cannot be separated by filters or semi-permeable membranes. They can pass through anything because their particles are so small. Colloids, another example, they can be separated by semi-permeable membranes but not by filters. They have medium-sized particles. Suspensions, on the other hand, can be separated by filters but cannot be separated by the semi-permeable membranes. As we can see from our picture right here, as for settling, we can see the suspensions has settled to the bottom because it's not being stirred, while the solution and the colloids are floating around in the water. With our filter right here, we can see that the suspensions are being caught by the filter and that the colloids and the solutions are being at the bottom because they aren't being separated by the filter. With our semi-permeable membrane is being represented by a bag and some water, we can see that the solution is the only thing outside of the bag, which is our semi-permeable membrane, while the suspensions and colloids stay within the bag. Now our learning check is based off of if we memorized all the differences between all three of the particles. So our mixture that has a solute particles that do not settle out, which means we can cancel out suspensions because they can settle out. Suspensions can settle. So our next clue is that they are too large to pass through a semi-permeable membrane. That means we can cancel out solutions. Because solutions, as we can see with our C example right here, we can see that they are going outside of our semi-permeable membrane. So that means our only answer that we have based off our clues is B, colloid, which is correct. So the next thing we're going to be talking about is freezing point lowering, boiling point elevation. I did have trouble with this one, so I had to include some visual representations in the form of videos. So when a solute is added to water, the physical properties change and the vapor pressure above the solution decreases. The boiling point of the solution increases and the freezing point of the solution decreases. And we call the vapor pressure, boiling point, and freezing point colligative properties. And they depend on the concentration of solute particles in the solution. So for vapor pressure and lowering, I got from a video that I will show in a minute that the vapor pressure basically is that the pure solvent, while by itself, the vapor pressure goes in and out as free will. But whenever a solute is added to the solvent, we can see that the water particles want to cling on to them instead of going in and out. So the vapor pressure decreases. And it decreases based off of how many particles are added to the solution. Are added to the solvent. Are added to the solvent because the solvent wants to go and attach itself to the solute. Now, I got this video that explained it to me right here.
And go into the vaporous state. So the water molecules at the surface are going to go back and forth in equilibrium into the pressure, the vapor around it, and back into the liquid state. So this is what we call vapor pressure. It's going to have some sort of pressure of gas on top of it. But let's say we put something in it and make it a solution. Okay, so I put some sort of like particle in this that was able to dissolve. And what happens when something dissolves is that their water molecules are attracted to whatever it is that's being dissolved, and they would rather be around that particular particle than escape into the vaporous state. So actually, the number of particles that are going to escape into the vapor is actually going to be lowered because depending on how many particles of solution I have. So the vapor pressure of a pure solvent is greater than the vapor pressure of a solution containing a non-volatile liquid. So why did I say non-volatile liquid? Well, something that's volatile is actually able to evaporate very quickly. So if I have something that's volatile in here, that'll actually make it escape a lot easier. But the fact that these are non-volatile, meaning that they like to be in liquid rather than gaseous state, then they're going to make the vapor pressure within this solution lower than it was originally.
So now our next topic is boiling point elevation. Whenever a solute is added to a solvent, we're going to use water in this case. Then that means the boiling point will rise. So the boiling point of water is 100 degrees Celsius. So whenever a solute is added to water, that means the boiling point will raise above 100 degrees Celsius. Because it's going to take more energy to boil the water and the solute. Now when it comes to the freezing point lowers. I had a hard time grasping this concept of the freezing point lowering. So I had to really think about how the ice and the salt interacted with each other. Because it doesn't necessarily melt the ice. It just decreases the freezing point to a point where the ice becomes water because the freezing point is lower than what the original 0 degrees Celsius was. So our next topic is osmosis, and it deals with how water flows through a semi-permeable membrane. So what water does is it wants to attach to a solute and make it more diluted. So it's going to cross through the semi-permeable membrane in order to get to that solute. And this also deals with osmotic pressure. So osmotic pressure is equal to the pressure that would prevent the flow of additional water into the more concentrated solution. So the greater number of dissolved particles in the solution, increases. So the more particles in a solution, the more solutes in a solution, the more that water wants to attack the solute, which means a higher osmotic pressure. Now, reverse osmosis, which is found in some plants that turn seawater into drinking water, they reverse that osmotic pressure and they force the water flow into an area where the solute isn't as high and forces it into a area where the solvent is higher. So it forces it into an area where the water is more prevalent than the solute. And I had to use a video in order to get it, because even though this picture provides a good, awareness of what's going on, I'm more of a visual learner. I like to see what's going on. So as we can see, the osmotic pressure in the semi-permeable membrane, the osmotic pressure. So we can see based off this picture and this picture that the amount of solute got lower and that the water rose because it's being forced into an area where the water is more higher. So this is normal osmosis, where it's trying to get into the area with the solute. And this is reverse osmosis, where the water that's mixed in with the solute wants to go with the rest of the water. So this is the video that helped me.
The core technology used at the Adelaide desalination plant is called reverse osmosis. First, let's explain what osmosis is. Osmosis is a naturally occurring process in which a liquid, such as water, spontaneously passes through a membrane. The membrane or semi-permeable barrier allows some molecules, like water, through, but other molecules, like the majority of salts, are unable to easily pass through the membrane structure. The flow of liquid through such a membrane occurs naturally to try and even out the salt concentrations between the two solutions. That is, the liquid flows from the less concentrated solution, such as fresh water, to a more concentrated solution, such as seawater. When the direction of liquid flow is reversed, it's called reverse osmosis. By pressurizing the concentrated solution, in this case seawater, we are able to force water molecules in the reverse direction, from the salty seawater side through the membrane to the freshwater side.
Okay, and now it's on osmosis and reverse osmosis. So hopefully y'all got the concept. If not, I'll provide some more pictures and videos to help you. So we're going to be talking more about osmosis as a whole, but we're going to talk about in relation to the amount of water and the amount of solution. So with an isotonic solution, in this case, there's an equal amount of both. And it's an ongoing process. So that means the ongoing of steady balance in isotonic, and it can be found in hospital IVs. So that a person's osmotic pressure when it comes to bodily fluids such as red blood cells remains constant. In a hypotonic solution, that means we have a lower amount of solute concentration. than the amount of solvent. So we have more solvent than we do solute. And in this case, we're using a real world example where we're talking about red blood cells. And as we can see that if you can see that, the red blood cell popped. And because it's become so swelled with water that it popped. The opposite is hypertonic. And that means whenever we have a higher solute concentration than water. So as you can see, this process is called crenation. And the red blood cells have become misshaped. And it causes it to shrink in size. Now compared to hypotonic, it swells. And hypertonic, that means we have more solute, it shrinks. And here's our overall summary. Isotonic is what we want. Red blood cells at a normal level where we have a balanced amount of solute and solvent. We have hypotonic, in this case it's called hemolysis, where the blood cells swell because of the too much water flowing into the red blood cells, causing it to burst and swell. And we have hypertonic. Hyper means we have too much solute in our red blood cells, and it causes it to shrink. Now, our next topic, we're going to talk about dialysis. Now, our last topic we're going to be talking about is dialysis. Dialysis is for those who have unhealthy kidneys and need a form of waste removal or filtration to happen in their bodies. And this can be through an artificial means. So in dialysis, solvent and small solute particles pass through artificial membranes, while the large particles are retained inside. Waste particles such as urea from blood are removed from hemodialysis. And it can be seen right here. Now I have a visual representation, but now I needed a video to see how it was done. So 1 second.
Are in charge of filtering waste out of your blood. But if your kidneys don't work as well as they should, you may need a procedure called dialysis, a process that removes waste in place of your kidneys. Let's talk about dialysis. Your kidneys have several important jobs. In addition to filtering your blood, they help maintain just the right balance of water, acids, and minerals in your body. They also function as part of the endocrine system, producing hormones. If you've had kidney disease for many years, or your kidneys have suddenly failed because of disease or injury, your doctor may recommend that you have dialysis, a treatment that replaces some of what the kidneys do, removing waste and excess fluid from your blood. It's sometimes used as a holding treatment while awaiting a kidney transplant.
As we can see from the video, he's provided a bulleted list of what dialysis does. And if short term, if you're on a way to receive another kidney, you will receive a catheter. But if it's long term and you plan on having dialysis for the rest of your life, it can be inserted through an artery. And with dialysis, it removes the blood and filters it, and then puts the blood back into the body once it's been thoroughly filtered out. So that was the rest of my presentation. I hope y'all enjoyed. I will provide some more videos and some practice problems, which has personally helped me. For my visual learners, I will provide some more pictures. And for my hands-on learners, I will provide some more practice problems. Y'all have a nice day.